Hello, welcome. I'm Professor G teaching you physics. Today's lecture is all about energy, various types of energy, and then eventually we'll arrive at work energy theorem. But before we start, you know what to do. Subscribe to my channel and hit that bell icon. Let's begin now. Okay, so let's look at energy. So what is this energy? That which enables an object to move is what we call as energy of a given object. So there are multiple types of energy that we have, but we're going to only focus on two types though, which is important for us. So which one? So first we have potential energy and then the kinetic energy. A combination of both of these potential as well as kinetic energy is what we call as mechanical energy. Mechanical energy is the energy in mechanics. So we say in equation form that we have here, mechanical energy equals to potential energy plus kinetic energy. Combination of both of these energies makes up mechanical energy. Now let's look at what is potential energy, right? Potential energy is stored energy held in readiness with a potential for doing work. Now for example, a stretched bow, right? Stretched bow, we stretch the bow. So this stretched bow has stored energy that can actually do work on the arrow that we stretch. Second example is where we stretch a rubber band for a slingshot that has stored energy to do work, right, on the object that we are actually stretching and holding it, and then we release the object, right? So let's take an example. I'm holding this object above the earth's surface. So work has to be done in order to hold this object above the earth's surface, and that is what we call as gravitational potential energy. So gravitational potential energy is defined as mass of an object times gravitational acceleration. G stands for gravitational acceleration, and h is the height at which this object is held. So let's look at this particular figure that we have. Here is the mass of the object, right? And then the distance where the object is held from the ground surface or earth surface, we call it as, small h. And then of course we have seen in free fall that there is gravitational acceleration that is always acting on the given object, which is equal to 10 meter per second square if you round off, or it is 9.81 meter per second square to be precise. So that's what we take the product of this mass of the object times gravitational acceleration times the height at which the mass of the object is actually held from the earth's surface is called as potential gravitational energy with a subscript G. Potential energy with a subscript G stands for gravitational potential energy. Look at some examples. We have two figures. Figure A shows us that it's a 15 Newton ball which is held on a vertical surface, right, of length 5 meters, and then we have figure B wherein it's an inclined surface and we have a 15 Newton ball held at the edge of the inclined surface, as you can see, and then the distance on the inclined surface is 20 meters. The distance of the vertical distance from the floor is going to be 5 meters for figure B. Now let's calculate gravitational potential energy for both of these figures and see what they are. So if I have to calculate potential energy, right, we know our gravitational potential energy is defined as mass times gravitational acceleration times the height. Let's say for figure A, your mass, which is 15 newtons, times gravitational acceleration. I'm just going to round it off to 10 meter per second square. And then I have height, which is given as 5 meters. So that would result with 750 joules, right? Potential energy, gravitational potential energy. For figure B, if we calculate the same gravitational potential energy, down the equation here, mass times gravitational acceleration times the height, it's 10 Newton ball, right, times gravitational acceleration 10 meter per second square, and then I have the height for the figure B is also still 5 meters. So I'm going to bring in 5 meters here, which results with 750 joules again. Go in both cases, the answer is still going to be 750 joules as shown here. The next type of energy is kinetic energy. Now, let's say an object is pushed, right? When an object is pushed, it is set in motion. When the object starts to move with certain speed, then it is capable of doing work, and that is what we call as kinetic energy. Kinetic energy is the energy in motion. So kinetic energy is defined as the product of mass and then the square of the speed. So kinetic energy in equation form is half times mass times speed square. So kinetic energy depends on mass and speed. The kinetic energy is actually measured, or SI units of kinetic energy is joules. So for example, this can be 10 joules or 20 joules would be a perfect example of kinetic energy. Kinetic energy is a scalar quantity. Just like potential energy is also a scalar quantity. Hence, it depends on speed and not velocity. Here we have an object of mass m, which is being held at the top of the inclined surface right here. Okay, so when an object is being held there, it has potential to do work, it has potential to move. So what we have at that point is all potential energy. And now when the object starts sliding down, right, slowly and steadily, let's say object starts sliding down, as and when it starts sliding down, the potential energy of the object starts getting transformed into kinetic energy. The distance where it is sliding down, right, there V picks up or speed picks up, correct? So as and when the speed picks up, your kinetic energy increases. Or just before it hits the bottom of the inclined surface, there is maximum kinetic energy, and then as soon as it hits the surface, it comes back to rest, and then kinetic energy gets transformed into potential energy. So right before, just before it hits the floor, we have maximum kinetic energy at that particular point. So the last concept of this lecture, work energy theorem, which is very important for us guys. So what is this? So gain or reduction of energy, or in other words, change in energy. It can increase or decrease, correct? This change in energy is the result of work. So in equation form, we say, work equals change in mechanical energy, because we are looking at energy in mechanics, right? Mechanical energy. So that becomes work equals delta ME, mechanical energy, or it's a combination of both potential as well as kinetic part, correct? So now we write it in equation form. So work equals delta PE plus kinetic part, right? Delta KE. Or it can be separately written as this way: work equals change in potential energy, or work equals change in kinetic energy. Okay, so coming to the last part, we have conservation of energy. Energy can neither be created nor destroyed is what we call as conservation of energy. Now, if it cannot be created nor destroyed, what happens to that? It just gets transformed from one form to another form. So we have seen two types of energy now. We had potential energy and we have kinetic energy, right? So that means it has to either go from potential to kinetic and then kinetic to potential, and that's what we call as transformation of energy. And this transformation of energy is nothing but conservation of energy. Energy can neither be created nor destroyed. Okay, so let's look at this particular example where we have an object which is actually held right above the earth's surface as seen here. So when the object is actually held at this position, we have complete potential energy. Why? Because object is not moving, right? It's not moving. There is no speed associated with it. it has potential to do work, but it's not doing any work yet. So that's your complete potential energy. And then complete potential energy of, let's say for example, 200 joules. Kinetic energy should be 0 joules because it is complete potential energy. Kinetic energy has to be 0. Now we have divided this path of the object into multiple parts. So let's look at 1/4 way of the object, and at this point we have potential energy of 150 joules. And then you see how object starts to move, your kinetic energy also starts to build up, right? So your kinetic energy is actually 50 joules. Now halfway through the path you have potential energy and kinetic energy, the mix is half and half. So you have potential energy of 100 joules and then the kinetic energy of 100 joules also. So now it's moving towards the surface of the earth. It's, we have seen this in free fall. It starts to gain speed. Now if we move it, if the object moves a little bit more, you can see potential energy decreasing and then the kinetic energy increasing. You see how it happened? It has potential energy and it has kinetic energy. As and when the potential energy is decreasing, you have kinetic energy which is raising up, right? So just before the object hits the floor, as in this case, your potential energy is completely 0. That means the object will have maximum kinetic energy. And as and when it hits the ground, right, when it comes to stop, then it has complete potential energy of 200 joules and 0 kinetic energy because there is no speed associated with it. So that's it for now, guys, and I'll see you in my next lecture. Bye-bye.